All right, guys, jumping right into the 4.3 and 4.4 notes for homework 11. I did want to note really quick, there is a 4.5 section in here. We are not going to do it. You guys can go ahead and completely get rid of this page. We're not going to do 4.5. It's not in the slick materials, so I'm not worried about it, so you guys can cross it out. So we're going to go ahead and jump into 4.3. So with 4.3, let's remember that we do know some things about these. This would be equivalent to the sine of alpha multiplied by the cosine of beta plus the sine of beta multiplied by the cosine of alpha. And cosine would be the cosine of alpha times by the cosine of beta minus the sine of alpha multiplied by the sine of beta. Okay. So the question is, if alpha is equal to beta, what would happen? What would this look like? Well, first of all, it would be the sine of 2 alpha, or the cosine of 2 alpha, right? And then how would these others on this side change? So let's go ahead and just look at sine for a second. This one would be the sine of 2 alpha would equal the sine of alpha times by the sine of alpha plus the sine of alpha times by the, oh, I'm sorry, I messed that up, cosine of alpha here. And then it would be the sine of alpha times by the cosine of alpha again. They're identical, right? So then we would have the sine of 2 alpha would equal 2 sine of alpha cosine of alpha. Or, if we went with cosine, we would say the cosine of 2 alpha equals the cosine of alpha times by the sine of alpha minus the cosine of alpha times by the sine of alpha. Because these are all the same. It doesn't matter. We can just switch them out. So again, the cosine of 2 alpha would be, well, hey, wait a second. What would something minus itself be? Oh, Mrs. Boyce messed up. Hold on, backtrack. I was a little confused by that. Cosine of alpha times by cosine of alpha minus sine of alpha times by sine of alpha. That one's better. So then the cosine of 2 alpha would equal cosine squared of alpha minus sine squared of alpha. That should look at least a little familiar to you. Okay. So what would the formulas be? Well, we would get that the sine of 2 theta would equal 2 times the sine of theta times the cosine of theta. Or the cosine of 2 theta could equal this, cosine squared of alpha minus sine squared of alpha. Other forms that it often takes, okay, would be 2 cosine squared of theta minus 1. That's one option. Another one that comes up a lot is 1 minus 2 sine squared of theta. So all of these, the reason that these work is it all ultimately comes back to the cosine squared of theta plus the sine squared of theta equals 1. All of that ties in with that. Okay, so that's where they come from. I'm not going to worry about showing you that right now, but just know that the reason I'm writing all 3 of these forms is because they do all come up a lot. So here are those. We call them the double angle formulas or the double angle identities. Double angle meaning 2 times the angle, double the angle. Okay. And then there's, of course, the tangent one here, too, that we haven't talked much about. But there they all are for you. So that's all great. How do we use them? Right? Okay, so first things first, we need to talk about the quadrant thing here. So if we're dealing with cosine of theta is equal to 28 over 53, where we are in the first quadrant, okay? But then we want to know about 2 times that angle. So if this is alpha, then the cosine is saying this is 28 and this is 53, okay? And then this, of course, would just be y, or our sine, okay? But we are not asking about that. In this, we're saying, okay, what if we doubled that angle? What would happen if we doubled it? So this one, we're going to jump in, and this would be 2 multiplied by the sine of theta times by the cosine of theta, right? That's what we know the formula would be. Well, in order to figure out what sine would be, we need to figure out what y is. So y squared would equal 53 squared minus 28 squared. So let's pull up a calculator here. This would be, so 53 squared minus 28 squared would be 2025. So y squared equals 2025. And therefore y equals, oh goodness, 45. So the sine then would be 2 multiplied by, now this is going to be 45 over 53. And the cosine we already have, it was already given to us, as 28 over 53. And then we would go ahead and multiply these all in. So 2 times by 45 over 53 multiplied by 28 over 53. And then I'm going to turn that back into a fraction if I can. Ooh, I cannot. Okay, well, let's simplify differently then. 45 times by 28 times by 2 would be 2520. And on the bottom, that would be 53 squared, which is 2,809. Okay. So apparently that doesn't reduce very prettily. Nope, it really just doesn't reduce pretty. That's just kind of where it is. Okay. So that would be the answer. We do need to double check if this should be positive or not. So I want you to think through quadrant 1. So if we're in this quadrant and we double it, it's potential that it could come over here. But all signs are going to be positive here, all functions are going to be positive here, and sine is going to be positive over here. Because this is sine, regardless of if we're here or here when we double, that's going to be okay. So this is all right. Cosine is a little bit trickier. This one could potentially come out negative. Okay, and again, it's because we could, if it's just a little one, it's possible if we double it, we stay in here. But if it was a bigger one to begin with, it's possible we go over here. Okay, so either are a possibility. We really don't know without knowing exactly what theta is. So we can follow this one's formula. And it's really up to you which version of this you use. I'm going to go ahead and use the cosine squared of theta minus sine squared of theta version of the formula. And so then the cosine, we already know the cosine. The cosine is 28 over 53. So all we have to do is square it and then subtract. And we already know what the sine is. It's 45 over 53. Square it. And then we just need to get an answer. So 28 over 53 squared. Ooh, it is not liking these ones today. So that's going to be 784 over 2809 minus 2025 over 2809, which would equal negative 1,241 over 2809. There you have it. So again, this one did end up being negative. What that tells us is that this angle is big enough that when we doubled it, we went into the second quadrant. Okay. Now tangent is, of course, we could use this formula, or we can know that tangent is really just sine over cosine, which makes our life easier because we already have those two values. So we're going to do 2520 over 2809. Divide all of that by negative 1241 over 2809. Of course, we can now use keep, change, flip. So 2520 over 2809 multiplied by 2809 over negative 1241. So these cancel. Yay, we love that. And then we would have 2520 over negative 1241. This one also doesn't reduce pretty. So we can just leave it like that. And again, that means that the double angle was big enough to put us in the second quadrant. So both cosine and tangent are negative. And that makes sense. Because they should be, right? Okay. So then when we move on to our next set of problems, we need to take a look here. So this one is telling us that we started in our second quadrant, okay? And we know that cosecant of theta is 4, which tells us that 1 over sine of theta is 1/4. So we are in quadrant 2 here. We're over here. Okay, so here's our little triangle. This is theta. Then that means that sine is, oops, sorry, I messed that up a little bit. So 1 over sine is 4, which means that sine itself is 1 over 4. So sine of being 1 over 4 means this is 1 and this is 4. Okay. And keep in mind, we're in second quadrant. This needs to be a negative, right? So x squared equals 4 squared minus 1 squared. So that's 16 minus 1, which is 15. So x is the negative square root of 15. And again, it needs to be negative because we're in the second quadrant, okay? So keep in mind now, when we double this angle, it could be going down into this quadrant or even this quadrant, depending on how big it is. Okay, so when we do this, the sine of 2 theta is equal to 2 times by the sine of theta times by cosine of theta. So we would have 2 times by, now sine we already have, that's 1/4. And cosine, we just figured out the other piece that we would need, so it's negative square root of 15 over 4. So this one would come out as negative 2 root 15 over 16 so far. We should reduce that if we can. So this is actually negative root 15 over 8. Okay, so sine is negative now. So what that's telling us is that we have moved to one of these two quadrants when we doubled. Okay, if we were still in this quadrant, that wouldn't be true, but when we double this angle, we have moved on to a different quadrant. Okay, cosine of 2 theta, let's use a different one than we did last time. Let's use, so we used this top one last time, so let's go ahead and use 2 cosine squared minus 1, 2 cosine squared of theta minus 1. So this one then would be 2. We do already know cosine. It's negative square root of 15 over 4. We would square that, and then we would subtract 1. So when we square this, we get 2 times negative 15, negative square root of 15 squared would be negative square root of 15 times by negative square root of 15, which comes out to a positive 15, and 4 squared is 16, which gives us 30 over 16. But we still have to minus 1. And of course this one is 16 over 16. So 30 minus 16 is 14 over 16, which of course simplifies to 7/8. Now this tells us that cosine is positive, which tells us we are indeed down here in quadrant 3. Okay. Tangent, again, you could use the formula where you already have both sine and cosine. I wouldn't. I think that's kind of tedious. So this is of course sine of 2 theta over cosine of 2 theta. Sine of 2 theta was negative square root of 15 over 8. And cosine of 2 theta was 7/8. So we keep change, flip it, our 8's cancel, we get negative square root of 15 over 7. And again, if we're down there in quadrant 3, tangent should be negative. And we're in quadrant 3 because we doubled the angle. Okay. All right, here's another one for you. This time we're given tangent, and we are in this quadrant. Okay, so I'm going to help you guys through this one because this one is suddenly having a variable, which is very different than anything we've done so far. So I'm going to go ahead and draw the picture. We know that we are in quadrant 3, so we're going to be down here. Here's our little picture. Okay, so if tangent is x over 5, that tells us that the opposite over adjacent is x over 5. So x and 5. Keep in mind, though, your x should be negative, and so should your y. And I'm going to switch. No, that's fine. We're going to leave it like that. And then this would be your hypotenuse. And I don't currently know what my hypotenuse is. But let's talk about how we would find it. We'll call it c. So your hypotenuse squared should be equal to a squared plus b squared. Well, negative 5 squared is easy. That's just 25. Negative x squared would be the same as just plus x squared. And therefore, your c value is the square root of x squared plus 25. Now, we can't go any further because we don't know what x is. But we do know that. So, when we're trying to find sine of 2 theta now, what we would do here is use our formula. So this is going to be 2 sine of theta times my cosine of theta. So we would do 2. Now the sine is going to be opposite over hypotenuse. So this is going to be multiplied by negative x divided by that whole big long hypotenuse we just found. So the square root of x squared plus 25. Cosine is your adjacent side, or negative 5, over that whole big long hypotenuse we just found, x squared plus 25. And then, of course, we can simplify this. Okay, 2 times negative x times negative 5, well, that's positive 10x. And the denominator would be the square root of this times the square root of this. Well, then you squared it, and it comes out just like that. Okay. So the sine of 2 theta is 10x over x squared plus 25. Cosine, let's go ahead and use another formula again. Let's use the third one. So 1 minus 2 sine squared of theta. So 1 minus 2 sine squared of theta, right? So 1 minus 2. Sine we already know. We know that sine is negative x over the square root of x squared plus 25. And we want all of that squared. Okay. So this gives us 1 minus negative x squared would give us x squared. And the square root of x squared plus 25 squared, those are inverses, so that's just going to give you x squared plus 25. Well, then that gives us 1 minus 2x squared over x squared plus 25. You could leave it here, but I don't think you need to find tangent in just a second, so it's a lot easier if you've simplified this a little bit more. So we're going to turn this 1 into an x squared plus 25 over x squared plus 25 so that we have a common denominator. And then that would give you x squared minus 2x squared plus 25 over x squared plus 25. Now you can combine like terms on the top. So x squared minus 2x squared is just negative x squared plus 25 over a positive x squared plus 25. That was interesting. So that's what our cosine is. And then to find our tangent, again, we just do it. So I'm just going to go straight to the keep, change, flip part. You guys know that this is coming. So this would equal (10x to the third plus 250x) all over negative x to the fourth plus 25x squared minus 25x squared plus 625. And of course we can simplify that even a little bit more. So we get 10x to the third plus 250x over you know what, I'm doing this the hard way, aren't I? Back up. These cancel. This is 10x over negative x squared plus 25. And you're done. Jeez, Mrs. Boyce, why are you doing it the hard way? Okay, so I hope I showed you all three of the different ways to use the cosine formulas. I hope that was helpful. So now we're going to move on to verifying identities. Okay, and I'm going to start on this side and realize that this is the same as cosine of theta minus sine of theta multiplied by cosine of theta minus sine of theta, which would give you cosine squared of theta minus cosine theta times sine of theta minus sine of theta times cosine of theta plus sine squared of theta. Now, of course, these are actually like terms in the middle here. So this is actually cosine squared of theta minus 2 cosine of theta times by sine of theta plus sine squared of theta. Okay. Now, if we switch the order of this a little bit, we can say cosine squared of theta plus sine squared of theta minus 2 cosine of theta sine of theta. Now, of course, you're allowed to do that as long as you take the plus with the sine and keep the minus with the 2 cosine sine. Okay. But this is 1. We know that's 1. Right? Then we know that the sine of 2 theta is equal to 2 sine of theta cosine of theta, which is exactly what we have right here. So we can say this is actually 1 minus the sine of 2 theta. And lo and behold, that's exactly what we were trying to get to. Ta-da! Okay. Here's another one for you guys. I think I want you guys to try these on your own. Okay? So I'm going to tell you, I'll give you a hint. On this one, get a common denominator. Okay, that's your hint on that one. And then on this bottom one, I want you to change tangent into something else. Start on the tangent side. And I think you guys can get it from there. I will post my notes, obviously, for that. But I want you guys to try those ones on your own. And go ahead and pause the video, do that. When you're ready, come back and we'll talk about 4.4. Alright, jumping in on 4.4. The first thing it's going to ask you to do is to solve these for specific things. And I think it would be helpful for you to try that. So if you want to pause the video again and try that out, I think that's a good idea. I think it's helpful. Okay. So once you've done that, you get that the cosine of 2 theta minus 1 is equivalent to the negative 2 sine squared of theta. And then, of course, you would have to divide by negative 2. And you get that the sine squared of theta equals negative 1/2 cosine of 2 theta plus 1/2. Or, if you leave it as a big ol' fraction, you actually end up with negative 1 plus the cosine of 2 theta over negative 2. And of course, we can pull those negatives out. So we can actually say sine squared of theta equals 1 minus the cosine of 2 theta over a positive 2. Okay, so this, what we just did, is the basis for this. You just proved it. Okay, and then this one, if you do it for cosine squared, something similar happens. So it's the cosine of 2 theta plus 1 equals 2 cosine squared of theta. And we end up with 1 plus cosine of 2 theta over 2 equals the cosine squared of theta. Okay, and that shows up here. And you'll notice the only difference is which one's minus and which one's plus. Okay, it's the only difference. Okay, and then tangent, you can figure that out by doing these two divided by each other. Okay, so those are called the power reduction formulas. They're very useful, so they're there. We also have what we call the half angle formulas, and I don't really want to get into like how we prove that, but you can, and you can YouTube it, you can figure it out. But I am going to tell you that these are plus or minus the square root of 1 minus cosine of theta over 2. That should look really familiar to you, right? It's the square root of that. It's not hard. Okay. And then cosine of theta over 2. Again, we're going to do plus or minus. And again, it's going to be 1 plus cosine of theta over 2. It's the same, it's that formula, it's just the square root. Okay. And then tangent is also similar, plus or minus the square root of 1 minus the cosine of 2 theta over 1 plus the cosine of 2 theta. Okay, and the plus or minus, it depends on which quadrant you're in. Okay, so it is plus or minus because it's a square root, but we also put it there to remind you it depends on which quadrant you're in, if cosine should be positive or negative. So cosine of 75 would be equivalent to the cosine of 150 over 2, which makes theta 150. So then we could say that this is equal to plus or minus the square root of 1 plus the cosine of 150 over 2. And of course, cosine of 150 on the unit circle would be square roots of 3 over 2, and that's all over 2. So then this, of course, is 2 over 2, which comes out to 2 plus the square roots of 3 over 2 all over 2. Okay, we can flip it here. Change, flip. Which ends up with plus or minus the square root of 2 plus square root of 3 over 4. And you know what? This should actually be a negative square root of 3 over 2. So this should actually turn into a minus right here. Sorry, so cosine of 150 is a negative root 3 over 2. So this should also be minus. Sorry, I missed a minus on all of this. Okay, so we can leave it there. We just have to decide if it should be plus or minus on this one. So keep in mind where cosine of 75 actually is on the unit circle. 75 is here. So that means that everything should be positive. All functions should be positive. So this is going to be the positive square root of 2 minus the square root of 3 over 4. Okay, so let's double check our answer here in our calculator. That is what the cosine of 75 equals. And then we want to check that that is the same as this that we have that we got. Sure enough, it is. So this is our correct answer. And there you have it. Okay. So with this one's actually a half angle, which sounds a little weird. But this one, you have two choices here. So you could actually do it this way like you're supposed to, the quote-unquote half angle theorem. Personally, I wouldn't. I would actually turn it into degrees. The sine of pi 12ths is 15 degrees. And then this is a lot easier to actually do. Hey, actually, that's the sine of 45 minus 30. And then say, well, then that's the sine of 45 times the cosine of 30 minus the sine of 30 times by the cosine of 45. And then the sine of 45 is root 2 over 2. The cosine of 30 is root 3 over 2. Sine of 30 is 1/2. And the cosine of 45 is root 2 over 2. Then this turns into root 6 over 4 minus square roots of 2 over 4. And then we can say this. It doesn't actually matter which one comes first, the 2 or the 6. I just, out of habit, write the smaller one first. Okay. So there you go. That's a lot easier. Okay. You could have done that a different way, and that's fine if you did. That's the one that makes the most sense to me. So now when we're trying to find sine, cosine, and tangent of these with our half angles, this one's a little bit weird. So when we are looking at this, it's telling us that the sine of theta is this when we are in our fourth quadrant, right? But we don't want to know about the sine of theta. We want to know about the sine of theta over 2. So how we deal with this is we actually take all of these and divide by 2 also. And we say that we are actually working in the range of 3 pi over 4 is less than theta over 2 is less than pi. Okay. So when we're looking at our answers, that matters as far as our positive and negative goes, right? So I'm going to draw a quick little picture just to kind of give us an idea of what we're working with here, because we were in quadrant 4, right? This was our triangle. This was our theta. And we were saying that the sine was negative 7 over 25. So that's fine. We still need our x value. So our x squared would equal 25 squared plus negative 7 squared. So that would be 625 plus 49. So that's 674. I don't know why I'm doing this the long way. We could do this a much shorter way. Okay. I don't really want a decimal approximation though, so I am actually going to backtrack a little bit here and find out what this is. So yeah, x should be the square root of 674. I'm just going to check if 674 is divisible by any perfect squares that are easy to deal with. Let's see, 4, 9, 16, 25 won't. So I think that that's probably the easiest form to leave it in. So we'll go with that. And then timeout. Mrs. Boyce is doing this wrong. Mrs. Boyce. It would actually be 25 squared minus that, and it actually does come out perfectly. And also, this is a Pythagorean triple. This is 24. Sorry, don't know what I was thinking. Okay, so now that we have all of those, okay, we can get that the sine of theta over 2 would be equivalent to, and we have a formula for this, it would be plus or minus the square root of 1 minus the cosine of theta over 2. Well, we can decide right now if it should be plus or minus. Okay, so again, this is the quadrant that we're actually going to be looking in for theta over 2. 3 pi fourths and pi, where is that? Is in quadrant 2, actually. Okay, so we're up here. So all students take calculus. The only one that should be positive is sine, but we are working with sine, so this actually should be a positive. And then we need the cosine of normal theta. Okay, so the cosine would be the adjacent over the hypotenuse, so 24 over 25. And all of that needs to be divided by 2. So we can turn this into 25 over 25 pretty quickly, which means that we actually get the square root of 1 over 25 over 2. And then this becomes the square root of 1 over 50. Okay. Square root of 1 over 50. And you're welcome to leave it like that, but that is the same as the square root of 1 over the square root of 50, which is 1 over the square root of 50. And 50 can be broken up pretty easily into 5 square roots of 2. And we could multiply this out and get the square root of 2 over 5. Oh, no, sorry, over 10 by rationalizing the denominator. The reason I did this is because I think these numbers are a lot smaller and easier to work with, and we are going to need to find tangent, so I think that's really helpful in this case, okay? So that's why I'm actually taking the time to do that, okay? So that was A. That was the sine of theta over 2. B is the cosine of theta over 2. And again, we're in quadrant 2, so the only one that should be positive is sine. So we're going to be dealing with a negative square root in this case. That's going to be 1 plus the cosine of theta all over 2, which will be the negative square root of 1 plus. Now we need the cosine of that theta again. And again, that's 24 over 25. All of that over 2. So 1 plus that would be 24 plus 25, would actually be 49 over 25. All over 2. And then we've got the negative square root of keep, change, flip, which comes out to the negative square root of 49 over 50, which is the negative square root of 49 over the square root of 50, which equals negative 7 over 5 square roots of 2. And again, I'm going to rationalize the denominator here. I just think it makes it easier to work with in the long run. Which equals negative 7 root 2 over 5 times 2 is 10. Okay. And then for C, it wants us to find the tangent of theta over 2. Again, you could use the formula, but you already have sine and cosine, so I'm not gonna. And I'm going to go straight to keep, change, flip. And this one's really fun because the 10s cancel, but so do the root 2's. And this comes out as a really easy negative 1 over 7. Done. Okay, and again, it's negative because we're in that second quadrant. Okay, when we divided it by half, we ended up here. Okay, some more examples. On these ones, I kind of want you guys to try these on your own. Now that I've shown you how to do it. And if you have questions, definitely let me know and I will post the completed notes. But I think the most beneficial thing for you is to really be able to do these, at least try them, and then let me know what questions you have. So that covers it for today. Enjoy your snow day. Don't work too hard, and I will see you guys on Friday.